we are going to cover in this session. We are going to look at what Packer is, what are the advantages of Packer. We will know the overview of Packer file formatting, formats which are allowed by Hashicorp. Then we are going to look at core components and commands of Packer. Then we are going to look at Packer workflow. And at last, we will see how to automate golden images build across multiple platforms. Simply, how to integrate this Packer in a pipeline. How we can automate Packer. So these are the things which we are going to cover in this session. I can confidently tell people who can make till end of this video can definitely understand or have a good understanding of Packer, and they can easily read any Packer files. Initially, I won't promise that you can write Packer files by the end of this video. We will make one more session for that, how to write Packer files. But yeah, any Packer files, it may be any format. You can easily understand what it's going to do if you are able to make till end of this session. Let's start. What is Packer? Well, Packer is an open source tool developed by Hashicorp in order to create an identical machine image for multiple cloud platforms using single configuration. We all know that we are having multiple cloud providers such as AWS, Azure, GCP, Alibaba Cloud, VMware, Linode, DigitalOcean, VMware. So many clouds are there. Cloud providers are there. Some are on-prem, some are cloud providers. And each platform requires its own type of image. What it means, in order to run an instance, spin up an instance in AWS, we all know AWS use AMI to spin up an instance. Well, can you spin up an instance or VM in Azure using AMI? Forget about Azure. Can you spin any instance or any VM using AMI other than AWS? Not possible, right? So that's where Packer is coming to help us. What Packer can do is, if your organization is working with AWS, and tomorrow if organization wants to adopt AWS along with AWS, Azure, GCP also as a part of multi-cloud program, there will be so many reasons why an organization want to go with multi-cloud, like cost savings, and some services will be maybe very much useful in some cloud providers. So keeping these things in mind, organization will definitely looking forward nowadays with multi-cloud. So in this case, whatever organization it might be, when it is going with multi-cloud, it definitely wants to maintain its workload consistent across these multi workloads. So till now your organization is working with AWS, all your workloads are running on AWS. So Azure and GCP also you are integrating, are taking in your company. So your manager will definitely ask you to maintain workloads slowly, not at once, slowly across Azure and GCP as well. So in this case, Packer can help you. How? Whatever workloads running on AWS, we can take that image as a base image, and we can create a image for Azure and image for GCP as well with same configurations. The moment we done it, we can seamlessly run our workloads across multiple cloud providers without any issue. So this is the idea of Packer. Well, what are the advantages of Packer? It is version controlling, cross-platform consistency, automate everything. Means, imagine you are having some workloads running on AWS. Can you know simply by looking at that AMI what all configurations it is consisting? No, right? But if you are maintaining that AMI or the base image with configurations in a file format, and which can be version controlled. Then easily you can make track of things, what configurations you are making, and easily make whatever change you like. So you are getting an additional control here. So version control is a plus which comes with Packer. Secondly, cross-platform consistency. As I told you, it's very big advantage. So even though you are on-prem or you are working on cloud, even on-prem, if your organization is working with on-premises also, like VMware also, you can take the base image or like ISO image also and do configurational change or convert this image or this workload to work across multiple cloud providers. Like you can convert this VMware ISO image to AMI VMware instance image also. Then automating thing. Just imagine for a while Packer is not there. Your organization till now worked with AWS, and now you want to create the similar environment in GCP as well. So what is the option you are having is uh, spin up an instance in GCP from one of the base image, and what all configurations you have done in AWS, you have to repeat them in GCP. After that, you have to save that as an image in GCP, so that in coming days, using those image, you can carry on further developments. So a lot of manual tasks need to be done in this case. But if you go with Packer, you don't need to do anything manually. Just you need to configure these things in a file and build it. That's it. Everything will be automated. So these are the advantages of Packer. Hope you understood these advantages. What is version controlling, cross-platform consistency, automating everything. So this is to work with Packer, we need to write Packer files. And these Packer files are available in two formats. One, we can write these Packer files in JSON format, and another one is HCL, Hashicorp language. So if we choose to go with HCL, then we need to provide an extension of file name followed with pkr packer.hcl. Now if you want to go with JSON, simply you need to follow this terminology, naming terminology, like packer file name.json. These two things are acceptable. So once you install Packer is going to give you some handful of commands, not much, like what you can see from screen. Packer build, console, fix, fmt, init, inspect, plugin, HCL to upgrade, validate, version. Well, this image itself is self-explanatory, even though I will tell some of the commands. This build is very important command. Using this build command only, like Packer build the file name, the template where we have written all our configuration, we can build the required image across multiple platforms. This FMT is nothing but it's like formatting. So if in your file is not formatted or you are not maintaining alphabetical sorting or some namespaces, if you are having multiple spaces, not maintaining a particular format, once you, after completion of writing your Packer file, you can simply write Packer format file name. Then what this FMT will do is, this command will do it will align all those things in a standardized way. Well, if you are having a Packer, previously your organization is maintaining some Packer files and those are in JSON, and now you want to, and you don't know JSON, you want HCL. Then what to do? Then you can go with this beautiful option, HCL2 hyphen underscore upgrade. If you give Packer HCL2 underscore upgrade file name of JSON1, the Packer will give you create one more file with the file name .json.packer.hcl. Simply, in simple terms, whatever things configurations which were written in JSON template, Packer is going to create one more file in HCL format. So you can start your configurations from that file onwards. And in it, to install the plugins which are mentioned inside the template. Inspect inside a file, we will use a lot of components like source, provisioners. These things we are going to discuss in coming slides. Just to tell, using this inspect command, what we can do is, without opening the file, we can have overview of what important components or what important modules are present in your file, like packer inspect file name. Validate command, if after writing your packer file, how you want to directly you won't run. First you will check for any errors. That you can do with this validation. We will be going through each of these command in depth in coming sessions. As I told you earlier, this session is only about overview, high level overview of packer and some general understanding about it. That's it. So before you can write anything or write your packer files, you need to know about some important core components of packer. If you are having a packer file, it will consist of different modules or different blocks. So those blocks are source, provisioners, builders, post provisioners, post processors, communicators, variables. So these are the important components of packer. You can take any packer file. You will find only those packer file will be composition of these elements only. Except these things, you cannot see anything more out of this. Yes, what I want to simply say is, no matter whatever packer file you take, you will find all these components or few of them. So let's look at each of the components in depth. First, source. So as we know the basics of a packer, the main thing of aim or main task of the packer is to create an instance or base image to convert a workload, to make workload consistent across multiple cloud providers. How it is possible? Packer is taking one base image from any cloud provider. It can be from VMware, AWS, GCP. Then Packer is executing some commands and making this image, converting this image to another platform usable thing. Like if you have taken a base image from AWS, you using Packer, you can convert this AWS image into GCP image or AWS Azure image or any other platform image, so that you can directly use that image to spin up instance in that particular cloud. So this source block is going to define or tell about more things from where you are going to pull the base image. Second, provisioners. What this provisioners is doing, once you have got the base image, you have to do some configurations on top of it. So how you going to do configurations? Packer is having two built-in provisions: file configuration, file provisioner, and shell script provisioner. It is also having we can also include like Ansible, Chef, another configuration management tools also in part as a part of Packer to make some configurations. So all those configuration related thing or stuff we can see in this provisioner block, or we can achieve them using this provisioner block. So just to give clarity, source block is nothing but from where you are pulling that base image, and more details information about that base image, all this stuff you can do in under source block. After getting base image, what all configurations you want to do, you can achieve that using provisioner block. Just understand on high level. So you have a base image, you have done some configurations. Now what's next? Now for what target platform you are taking this base image, like to what cloud provider you want to convert this base image. For example, you have taken base image from VMware ISO1. You want to convert this into AWS AMI. In this case, AWS EMI is your target cloud provider, target platform. Those all things target related to target platform we can define in builder block. We can achieve them using builder block things. So you got a source image, you have done some configurations, you have already assigned the target platform to which these are meant for. Then comes post processor. What this block do is what set of tasks or what set of things you want to perform once the image is built. On top of that, those all things you will define under the post processor. For example, you can once the image is built, you can compress that one, convert that image to another format, or simply upload to somewhere else. So all these things, once the image is formed from source image, you have done some configurations. After doing some configurations, you have converting that source image base image to and target platform version wise. After that image is formed, you can perform some set of tasks using this post process. Then comes communicators. Packer is having mostly two kinds of communicators. One is SSH, second one is WinRM. So what this communicator do is, once you have taken the base image, done configuration, defined the end platform, after formation of image you have done some commands, run some commands on that, everything is good, fine. Then using this communicator, Packer will connect with or SSH to the instance in the target platform in order to build image in that platform. So SSH is used in case of Linux instance. If your target platform, you are creating some Windows instance, in that case WinRM communicator is used. So this is about communicators. And lastly, variables. Variables are nothing but key value. We can store our information inside the variables. So in this Packer template, we can introduce variables to make it more user friendly and more usable, reusable, instead of doing hard coding, so that we can use this Packer file across multiple environments. So in this way, variables are going to help you. Just to summarize, we have seen what is source, what is provisioner, what are builders, what are post process, what are communicators, what are variables. So these are the core components of Packer file. As I told you, take up any Packer file, you will see these things only. So number one, first thing, we will take base image. From where we have to take base image, what kind of base image, everything will be defined under source block. Then what kind of configurations you want to do on top of that base image, those things you will define under provisioners. Then for what is the end, our target platform for which you are doing these things are defined under builders. This Packer can have multiple builders. That means base image can be converted into multiple images, golden images, in a single shot. Then after creation of that image, you want to make any kind of operations, those kind of operations are defined under post process block. After that, we are going to use communicators to connect with that instance in the target platform. And variables, as I told you, we will use these variables to make the Packer template more user friendly and more reusable. So this is about the core components. I hope you understood what I have said. Just don't try to go deep all at once. Just understand what is Packer. Packer is nothing but it is a kind of tool which is going to help you in creating one platform image to another kind of platform image. That's it. If you are taking a base image from AWS, you are working in AWS, your workloads are in AWS, you want to migrate or you want to explore some other cloud, and you don't want to start from scratch. You want to start from where you left in AWS. In that case, what you have to do, simply take a packer, write a packer file, taking the base image of AWS and to what cloud you want to migrate or work with. Suppose Azure. Mention that Azure in builder session, run the packer. Then this you will see AWS image AMI will be converted in Azure one. So that using that image you can spin up a VM in Azure and you can carry on. So in this way we can achieve similar workloads across multiple or different cloud providers. That's it. So what is Packer? You understood. Packer is how to work with Packer. You need to write some Packer files. Two kinds of Packer formats are available. One is JSON, second is HCL. Then while writing Packer files, you need to know about these components. 6 components that you have known. That's it. Till now we have discussed that much only. Let's see. So this is the Packer template which I am talking about. So you can see source, you can see here builder, you can see here provisioner, you can see here provisioners. Okay, you are not able to see here post operations, post processors, because that is optional. Okay, everything, just because you know all these components, it doesn't mean that you can you should definitely indulge every core component inside a Packer image. No. So out of these things, source is mandatory. Without source, no use of writing Packer file. Provisioners is also mandatory, because if you want to do any configurations, then you are going to use this one. Builder is also mandatory, because this is the end platform where you are going to define. Communicator is also mandatory, because whatever the end product end platform is there, what kind of instance we need to connect with that. And variables is optional. Okay, so post processor and variables are optional. You can include them or exclude, it's up to you. So just now we have saw core components of Packer. So if you have understood that well, so this is one of the example of Packer template. You can easily understand by going through this template. You can easily understand what this template is meant for. Like, you can see source. What I have told, source will deal about the base image, from where the base image is coming and what kind of base image, and all those stuff will be coming all under the source block. So if you can see here, source block AWS EBS, you are able to see more AWS stuff here. That means the base image which you have took is from AWS. So this is nothing but we are using some source AMI filter. This is for filtering of AMI. We are not simply hard coding one AMI ID, which we can do. What we are doing is making the script more dynamic. So under this source block, we are writing one source AMI filter, which is filtering using these attributes: name, root device type, and virtualization type. When the Packer finds one, it is going to take that as a base image. And SSH username we are giving Ubuntu. So as I told you, there are two things optional. One is post processor and second is connectors. So if we don't mention anything about the communicators, then it's the default one is SSH. That means that Packer is going to connect with a Linux instance. So for that purpose, we are giving here SSH username. Then we are going with builder block. As I told you, in builder block, we are going to define what is the end platform we are targeting. So here also we are referring the same source, that is the end result and end platform for which we are building all these things is also here AWS. So here provisioners, what I told you previously, provisioners are for configuration purpose. So here we are using two kinds of provisioner. One is file provisioner, second is shell provisioner. In file provisioner, what we have done simply is we have copied one file locally and we have transferred or shifted that file to the place where the new image is getting generated, to the golden image. Simply now this script.sh will be a part of newly created image. That means the base image will not having any knowledge about this script.sh, right? But once this configuration is done, the gold image is formed. When we spin up that image instance out of that image, the script.sh will be a part of that newly formed image. That's the main idea. Secondly, we are using shell provisioners. So if you want to copy any files, you are going to use file provisioners. But what about if you want to run some shell scriptings, some shell commands? In that case, provisioner shell is going to be used. So what we are doing here, whatever shell script we have copied, we are giving execute permissions and trying to execute it while the image is building up. And what is inside this script.sh, it's nothing but installation of docker commands. I have put that one. That means what will happen once we build this packer file is it's going to pull a base image from AWS of Ubuntu with whatever parameters we have mentioned. Then it is going to simply copy one file script.sh, then then it's going to run while formation of the new image, golden image. So what will happen? Previously, what is the base image we have took? Docker is not the part of the base image. But once the output, what is the gold? Once we get a golden image, so when we spin up an instance, that instance will by default or automatically Docker will be a part of that. So that's the beauty of this packer. Hope you got it. So let's see diagrammatical approach, what we have discussed till now. So if you are having a workload, for example, assume that you are working with VMware on premises. So you have got one ISO image. So you need to write in a packer configuration, taking source as source from VMware and building and you can define multiple builds, like you can see, and end platforms we are aiming is AWS, Azure, GCP. So in this case we need to write or define 3 builds in our packer template, one for AWS, second for Azure and GCP. And using provisioners we will do some set of configuration on top of base image. That's it. Once it is done, we are going to give some packer command like packer build a packer file name. Then what it will happen is this ISO image, what is there previously, will convert into AWS, Azure, GCP. These 3 clouds are getting their own images where workloads will be same. So this is the beauty of packer. So we are going to look at one more diagram which is in depth. So we will nothing but whatever we have discussed previously, that only in more depth, more pictorial way I am showing you. As I told you, in packer you need to take a base image, it is empty, and during in packer template you can define, like you can add some files, run some scripts, you can add some upgrades, OS patches, some tools, security elements. You can even not only file script provisioner, you can also integrate the packer with some configuration management tool like Ansible, Chef, Puppet to do configurations. So once the base image, by pulling base image, if we run this packer command, the output will be the golden image, which in this golden image you can see file is a part, tools are part, scripts are the part, securities are also part of this golden image. So irrespective of end cloud, with this golden image, if we are going to spin up an instance, all these things will come by default. So this is the what packer is doing at higher level. So by this time you will get it out. if anyone having some knowledge on AWS, when spinning up instance, you will see one user data field. That is nothing but a script which is going to be run during launching of the instance. Now you can ask me, Sampath, why I have to learn Packer again, that HCL templates, core components and all. What you have simply done, took a base image. Okay. On top of that, you have copied some files, installed some tools, some security patches and all, run some script. All these things I can do using AWS user data. While simply launching the instance, I will go to advanced tab, and whatever configuration you are maintaining in this uh, packer.provisioner field, all those commands I will simply put it here and launch an instance. So why waste of time? It can be done, right? Yes, whatever you have taught is right, but there is a key point. At Packer, you are doing all these operations at image level, but when you are using this user data, you are not doing anything on the base image. You are simply running this script at the launch time of the instance. Then what will happen? It will take more time for the instance to get ready. So, okay, let it take. What is that? I'm not having any hurry. You might think like this, but it's not the thing. Let's see. In AWS, I'm sure that everyone will be familiar with this auto scaling thing. Generally, auto scaling groups will use AMIs while spinning up the instance. So look at this first scenario where only one user is connected with the load balancing, and one instance is he is running his workloads on one instance. He's getting served by this instance. When one more user got added to this network, traffic got increased. This single instance is not able to bear the traffic. So what auto scaling group has done is spin up an instance with using that AMI. So in this scenario, if you are going to use this user data while launching at this instance, all those configurations will be installed in form of script. Then what will happen? The user too we have to wait for longer time, because this instance which is spinning up is not ready to take traffic yet, because it is busy with installing configurations. Okay, if third user also add, again the auto scaling group will spin up one more instance again. For suppose in this case it has took some 5 minutes to install, so again the new instance will also take 5 more minutes. So this is bringing a very lag, and very bad user experience will come out of this model. So if you go with Packer, while creating itself, Packer will take some time, and once the AMI image is ready, which will be a part of auto scaling group, then whenever traffic workload we need to spin up an instance, it use that AMI where all these configurations are part of that. So the user can access that workload or that instance instantly when you compare to the this AWS user data. I hope you understood what I'm going to convey. Yes, using user data also, you can do configurations at the configurations, but this is our at launch time, so which is going to introduce a lot of lag. The application performance will be slow, and user experience will also be very terrible if you are going to use user data in auto scaling time. So whatever we have discussed, I have represent the data in tabular form, where you can see the purpose of Packer, purpose of AWS data, user data. See, customizing the instance behavior during launch time. So what is the end result is startup time may extend startup time during execution. But when you see the Packer, fast startup time with pre-installed configuration can be achieved using Packer. So that's the beauty of Packer. So very important thing. Okay, we have written some Packer template, Packer file. We are executing some commands. Then what will happen once we execute Packer build, Packer file name? what internally it will happen. Let's look at here. So once you are ready with a Packer file and you start giving a command Packer build Packer file name, then what Packer is going to do is initially look for VPC related information inside that configurations, inside that template, because if you have not mentioned any VPC related information, what Packer will do is it go with a default VPC in AWS, as we have taken the target platform AWS for simplicity. So if we have not mentioned anything related to VPC, private VPCs, then default VPC will be selected. Then base image, it is a very important thing. It will search for the base image. Once it get a base image from AWS Marketplace, then it's going to create a temporary key pair in AWS. Then it's going to create a temporary security group and then add some inbound rules. As we have discussed earlier, Packer need to connect with the image or instance to create an image. So for that purpose, it is creating a temporary security group, temporary key pairs, and it is adding an inbound rule so that it can SSH into that instance. Then it will launch an instance with the base image we have obtained from AWS Marketplace. Once the instance is up and running, it will execute some commands to build the image of yes. So once the image is instance is created, the Packer will SSH using the temporary key and security groups. Then what it will do is it will stop the instance after running the required scripts. Then once the AMI is created and the instance will be terminated. So as you can see, we have taken a base image, done some configuration on top of it. We have created an instance at a target region where we want to create a golden image. So that instance will run some scripts to create a golden image. Once the golden image is created, we are not having any use for this instance. So we will terminate this instance. That's it. Then we have to clean up stuff. Whatever, while creating this instance, an EBS will be created and background that will be cleaned up. And if any additional volumes we have written in configuration file, those things will also be cleared up. After this, it will delete the security group as well as key pair. So that's it. So this is the workflow. You can easily see from base image to golden image. This is the journey of the Packer. So whatever we have discussed, I have put the data in a workflow in a tabular form. Just have a look. And this is the console output. I have taken a dummy file to just show you what all steps we have gone through. So you can see here, as it is dummy one, I have not made any configuration on top of it, just taken a base image and simply run that template. We are not doing any configuration. That means base image and end image, golden image both will be similar. Why I have done that is to just show you these steps one by one, the flow. It has took 3 minutes 9 seconds to complete. So this is the workflow of the Packer. Now every time I am saying golden image, what is golden image? Golden image is nothing but it is an image which is coming with predefined or default packages or something softwares or application which are not part of base image. So anything we configure on top of base image, the image we get is known as golden image, and companies are going to maintain this golden image in their own private repositories. So whenever they are having that requirement, they can simply pull that one and use those golden images. So as I told you, after knowing how the Packer is going to build, now it is important to automate stuff. We can't go into Packer CLI and always manually we can't give commands. So we need to make it a part of automation. How we can do it? Like we can take help of Jenkins for CI/CD, and as I told you, with Packer we can integrate configuration management tools also for doing some configuration stuff. Here you can see we are maintaining Packer templates in GitHub repository. Whenever some code commits or some changes occur in that repository or in this file, Jenkins is going to pull those things and run the Packer commands for that. And this Packer is taking help of Ansible to do some configuration over it. And in single run, this base image is going to convert for Azure, AWS, and GCP. So in this way, we are able to maintain consistent workload across multiple cloud providers. So if you understand the concept, we can play with these things. Like here the central element is Packer. We can change other things according to our use cases. Like I don't want to use Jenkins as CI/CD. I want to use GitHub Actions. Well, you can do it. And I don't want to use GitHub Actions also. I want to use GitLab. You can do that one also. And now not about CI/CD. I just want to go with some Chef or some Puppet like that. I don't want to go with Ansible. That you can do that one also. Chef or Puppet. And it's not about these things. Even the cloud AWS, Azure, GCP have mentioned these three things because they are more famous. Even you can change those things also, like VMware, Linode, DigitalOcean. Okay, so once you understand the flow, you can change the tools accordingly. So let's build a small project on whatever we have discussed so that you to have a better understanding. So what I am doing is simply I have taken AWS as a end product, as well as I am taking the base image also from AWS. Why, Sampath? I know only AWS as of now. Soon I will work on GCP and Azure also. So that's why what I am doing is I am creating a Packer configuration files, putting them in my GitHub repository. Idea is whenever some change occur in these GitHub repositories, Jenkins will pull that one and run some Packer commands on top of it. So I'm not using Ansible also as of now. I'm simply using shell provisioner to do configurations on top of base image. And once all these things are done, our golden image will be ready in our AWS. So previously whatever script I have shown you, it's the same thing which we are going with. Okay, so let's move. Okay, so this is the GitHub page. So this is the GitHub page where I am maintaining my source code. Like I have shown you before, this is the shell.sh, and this is a Packer template, the same one. So what I am doing is copying this GitHub repository, going to Jenkins. We will create a job. Oops. Okay. We will create a job. We will simply create a freestyle project. Packer. We will create a Packer job. So we will go to Git. As it is a public repository, we don't need to give any credentials, and take care of this branch. I am having main, not master. If you don't see this one, you're going to fall in some trouble. That's it. So once this thing is done, I just want to execute some shell command like so I want to build packer.init I'm using wild character. Hope you understood what I'm trying to do. HCL. As I am maintaining these two files, we can directly copy paste this name also instead of wild character. So once these two files are part of this repository, GitHub repository, which we are linking in this job. So once it will clone, these two files will be available in Jenkins. What I have previously done is I have installed Packer in Jenkins. See, I am running this Jenkins instance in Mumbai region. In this Jenkins region, its instance itself, I have installed Packer so that Jenkins will be able to run Packer commands. So this is the thing I have done. So let's apply, save. So I have not configured any GitHub webhook or any other kind of pull SEM or all those things to keep the things very simple, because our main intention is not about Jenkins and all. It's all about Packer, understanding its workflow. So I'm not complicating things here by creating some pipeline or some complex stuff like that. So simply what we have done here, you can see I have created one job. I have given my repository here. It will simply clone that one once this job is run. Then after this job is executed or triggered, I want the Jenkins to execute this Packer build AWS ubuntu.pkr.hcl file. That's it, as simple as this. And one more thing you have to observe, that whatever code I am maintaining here, nowhere I am using authentication access key, AWS access key and all. Actually you need to authorize, but by including some AWS keys and all, I have not done these things here because I am using AWS instance role. You can see in security modify IAM role, I have attached an EKS role. Previously I have created this one. This role is having administrative access. So simply what I have done is, what the instance where Jenkins and Packer are running, I have given that administrative access with role-based access. Instead of defining AWS access keys in code or using environmental variables, I have simply given a role for that instance for authorization purpose. And inside a code, once the image, the target image should be built in this region, US West 2, Oregon. In this region, I have configured the image, the Packer to create image for me. So let's build now. Let's see the output. Already Packer command got executed. See, we are able to see all these things. Pre-validating VPC information, as I told you, it will first check for VPC information, then it will check for the base image by taking the constants, whatever parameters we have passed in that search filter. So it has already found one image with AMI, this one. Then as we have discussed, it is creating a temporary key pair and a temporary security group, as we have discussed. So it has added one inbound rule. Then it is launching a source AMI instance. It is, and it also instance ID also got. That means in this Ohio region, by now we should find an instance. See, it's running. So now what this instance will do, it will execute some commands to build image, our image in AMI section. We can see, we are not able to see here because it will take some time. Yeah, all these configurations are running. Unpacking container, preparing to unpack. So once the instance work is done, it will be stopped. It is running, then that means configurations are still working on. That's the reason. Once the required configurations are done, this instance will stop. See, I have told you. Now we can see one AMI getting created in this one. Please be patient. Have some patience. See, it has created one AMI which is in pending state. So the moment it's going to become ready, the instance here which is stopped is going to be terminated. I want you to see it very closely. The moment it's been pending state, the moment the status is going to be ready, the next second this instance is going to be terminated, as we have discussed in Packer workflow. We can see, observe this one. See, waiting for AMI to be ready, Jenkins job. Once it is ready, the instance will get terminated, and what all resources it has created, like see, this instance will be having one volume here. This volume will also get terminated along with the ones the instance got terminated. So it's taking some time. So can you predict what is happening right now? Docker is getting installed in this, becoming a part of this base image. That's why it's taking some time. The moment it become a part, with this AMI, if we launch an instance, we can directly work with Docker. That's the beauty. Okay, we will see from this here only, waiting for AMI to be ready. In Jenkins console, we will see. Generally, how much time it will take for installing of Docker? Similar time it will take. So we need to be patient. Have some patience. This is the server where Jenkins is running. It's in Mumbai region. Yeah, you can see waiting for AMI to be ready, skipping enabled. Yeah, now you can see this instance is getting terminated. That means the volume will also get terminated. See, no volume, it has cleaned up, and by this time the image will be ready, active, available. That's it. This is the workflow. See, previously there was a 8 GB volume, but now it is not there because Packer has cleaned up those stuff. Instance also got terminated. Now you can check. We can launch this instance from this AMI. We will do it now, right now. So golden instance, as it is spinning up using golden image, we are going to give that name, instant type and all key pair, I am taking this one. That's all. Launch this instance. Golden instance. Give it some time so that it will be up and running. The moment it get ready in running state, we will see it here. Right now it's in pending stage. Right, it is running right now. Let's connect and see. So I am maintaining all these PEM files in my current directory, so I don't need to waste time for all those things, connection related stuff. Right, so this is the golden instance. So according to the concept of Packer, we have spinned an instance using golden image where Docker was installed. So if I type Docker, it should come up. See, Docker is a part of this image. We can execute Docker images, Docker volume, ls, all. See, Docker is a part of this image. That's the beauty of Packer. So that's it here. That's it, friends. Thank you for staying till now, till the end. I hope you people got some valuable stuff. Thank you very much. If you want to reach me out, this is my LinkedIn profile. I would like to hear any feedback from you. Thank you. Thank you very much.